About the fourth type of double sideband full carrier detection. So the fourth type is envelope detector, or due to the device diode we can call it a diode detector as well. So the circuit diagram of the envelope detector is something like that. So where you have input signal is the amplitude modulated signal which will enter into the diode, and you know that the diode is a rectifier. So it means that for the positive peak signal the diode will be reverse or forward bias, and for the negative cycle the diode will be reverse bias, and it works as an open switch. So and then after that the capacitors start charging and discharging through the resistors. So let's see first how it works. So let's understand first the working of the circuits, taking a simple sinusoidal signal. So suppose we have the sinusoidal signal, sine wave. So this is the sine wave at the input of the diodes. So this one is the diode, and this is P junction, P type, and this is N type. So we can have both values, positive values and the negative values at the input of this diodes. Let's suppose at time t. So the initial condition, we know that Vc at t is equals to 0 is always equals to 0, means that initially capacitor has no charge. The value of the voltage of the capacitor is 0. So initially the input is also 0, the output is also 0, so that is why both potentials are same, so that is why the diode will not start working. So at time t the diode work as a reverse bias or in the normal conditions at t is equals to 0. So this one is 0. So at 0 there is a no the working of diode is not operating. The second point, so let's suppose if the time is t, so this t is equals to 0 plus 1, means that we have a voltage, some voltage. So the voltage is, the value of the voltage is something like this, maybe any value like 0.1 or something like that, 0.1 volt. So the value of so 0.1 volt means on the negative side there is a 0 volt, positive side 0.1 volt. So it means that the diode is a forward bias and it will work as a closed switch. So we also consider that the diode is ideal. So as t is equals to 0 plus, a 0 plus, input is just greater than 0 because at this side the output is 0. The diode is ideal and the capacitor will charge up to the value of 0.1. If we suppose it is 0.1, and then in that case it is work as a closed switch. And then the capacitor, like the capacitor is start charging. So if the input reaches at point t1, so suppose the input is equals to t is equals to t1, so that is the maximum value A. So in that case the capacitor, the diode still has more voltage, so it means that the capacitor will have the value up to the level of A. The capacitor will charge up to the level of A at this particular point. Secondly, if the input, after that you can see like from here to there, the input is keep decreasing. So from here to there the input is keep decreasing. So it means that the potential on the other side is bigger than the potential on the input side, on the P side. So that is why in that case the diode will be open switch. So the diode will be open switch because we have more voltage on the negative side and the less voltage on the positive side. So maybe that is the case. So if that is the case, so it means that the capacitor, so this is open, so this one is open circuit, so it means that the capacitor will discharge. So the capacitor, so initially the capacitor was charged up to the value of A, and then when the input voltage start decreasing, then the diode will be working as a open switch and the capacitor will start discharging through the resistor. So the capacitor, you can see the capacitor start discharging through resistors. So if we explain the same method like in more detail, so we can have this signal and we can express that signal in a large scale. So it means that that is our A and this is our negative A. So minus A and then plus A. And this is the, so this line is a straight line. So straight line is called the envelope. So this is the straight line and straight line is called envelope. So that is the sinusoidal wave. So up to this value, so the capacitor is charging. The capacitor is charging. So this is the charging capacitor, and then from there, so you can see it is the voltage is keep decreasing. So when the voltage is keep decreasing, the capacitor start discharging. So capacitor discharge up to a certain level. Here at T is equals to T2. So up to here the capacitor discharge. So it means that here we have a discharging curve. So where the voltage on both sides of the diode, like the N type and the P type, both have same potential. So after that you can see again the voltage start increasing. So if the voltage start increasing, so it means that the capacitor again start discharging. Why? Because the diode will be again working as a closed switch. So from here again capacitor start charging, and it will keep charging up to T is equals to 3 when the time is 3. And then after that, so you see it is again discharging because the voltage is keep decreasing, and then it will again discharging up to that point, and this process continues. So usually the separation between these two lines is very small. That the upper line is envelope, and this line is the discharging line of the voltage, and this line is the charging line. So you can say that here diode is on, and here so you can say that the diode is off. And then so this is charging, and then this is discharging. So you see that you have so you can see that you have this type of waveform, like here and then start there and then there and then start there. So these are the ripples. So it means that you are not getting exactly the envelope. So you are getting some ripple in the waveform. So using the smoothing filter, you can remove these ripples. So you can give the VC to the smoothing filter, and the smoothing filter will work like so. If you see the drop of the smoothing filter, so up to here it is working like this, and then after that it is working as a straight line. So that is the envelope of the detector. So it follows the input, and then after that you will get the envelope. So like overall, so this circuit is working like this. So if we explain in the form of the modulated signal, so this is our modulated signal. So this is our modulated signal that is being inputted from the input side, and then the diode start working. So it means that we know that half of the side will be gone away, and the remaining is only the upper side. And you know, so the upper side is this one. So start charging and then start discharging. 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 Charging and then discharging. Charging and then discharging. So this is the curve. And then you can see, so in that way you are getting the exact envelope of the message signal. So that is why the name is envelope detector, and because we are using the diode, so that is why the name is diode detector. So to get these conditions, to satisfy that, suppose we can have this type of waveform, so there is a condition that must fulfill. So this is the RC, time constant of the diode. So we have R and we have C. So this is the RC, so that must be much bigger than 1 over FC, or you can say that must be much bigger than the time period of the carrier, and that must be much lesser than the time period of the modulating signal or the inverse of the modulating signal. On the other side, if it doesn't follow this condition, if it doesn't satisfy this condition, then what could be the case? Case 1, suppose that your RC is much less than FC. So if it is much less than FC, so what happens? So this is the modulated wave, so we are just taking the upper half side, because we know that the negative side, due to the diode, the negative, there will be no negative side, we only have positive side. So due to this, what happens? So if that is the case, the diode, like the capacitor discharge, so charging here, so and then the capacitor like discharging is very fastly, so from here to there, and then you see charging, and then from here to there, so you see, and then charging from here to there. So it means that you can see it is not following the envelope. So it does not follow the envelope if this is the case. It can be second case as well, like if RC is smaller than the inverse of the modulating frequency, then what happens? So again the same wave. So what happens then? So charging, and then diode will start discharging, and then charging, diode will start discharging, charging, and the diode will start discharging. So you see, like the capacitor discharge very slow. So if the capacitor discharge very slow, so it will keep missing many peak values. It will keep missing these peak values. So if it will keep missing these values, so this type of fault is known as diagonal clipping. So if you are selecting RC is much bigger than the inverse of the modulating frequency, then you will have a diagonal clipping fault. So to avoid the diagonal clipping fault, you must have to have RC smaller than the inverse of the modulating signal. So that's all for today lecture. So I hope that you understand the envelope detector or the the diode detector very well. So if you still have any question in your mind, so you are most welcome. You can write the question in the comment box, and we will answer that question. So keep subscribing our channel and like our channel, so that you can see the next video. Thank you for watching the lecture.